Imagine predicting the weather. If it is sunny today, there is a good chance it will be sunny tomorrow. But if it is raining, maybe it's more likely to be cloudy. This simple idea that the future depends only on the present is the foundation of a Markov chain. A Markov chain is a system of states and transitions. States are the situations we can be in, like sunny, rainy, or cloudy. Transitions are the probabilities of moving from one state to another. For example, a 70% chance to stay sunny, and a 30% chance to become cloudy. The key features is the Markov property. It says, history doesn't matter to predict tomorrow. You only need to know today. You don't need to know what happened last week or last year. The current state contains all the necessary information. Now, let's make it interesting. Let's add an agent. Instead of just watching the weather change, we can take action. We can choose to walk or drive. This transforms our chain into a Markov decision process, or MDP. Now, we are not just observing. We are influencing the system. But how do we decide which action is better? We need a goal. In AI, we call this a reward. If you walk and it is sunny, you get a positive reward. Happiness plus 10. If you walk and it rains, you get a negative reward. Wet clothes minus 50. The goal of the agent is to collect as much reward as possible over time. The agent explores the states, tries different actions, and learns from the rewards. Over time, it builds a policy, a cheat sheet, telling it the best action for every situation. From playing chess to driving self-driving cars, RL agents are just navigating complex Markov chains.